Yo, what's up everyone? Welcome to Equilibrium Part 3. So we're going to talk about the relationship between Ka and Kb. This usually makes up like one question or two questions on the test, but it's cool regardless. So let's do a little review of what an acid dissociation looks like. So the general form is going to be Ha and it's going to react with water to produce hydronium and A- ions. So the Ha is the acid, the water is the base, the hydronium is the conjugate acid, and then the A- is the conjugate base. The Ka value for this is going to look something like this. It's going to be H plus the concentration of hydronium times the concentration of the A minus over the concentration of the acid. And similarly, if you look at the general form of a base, it's going to look like this, where A minus, the base, reacts with H2O, the acid, to produce Ha, the conjugate acid, and then OH minus, the conjugate base. And the Kb value looks something like this. Now, this is interesting because if you took those general forms together and you added them up, you would get the autoionization of water. So this could kind of be a coincidence, but what if we look at multiplying the Ka and the Kb values together? Well, we get something like this. And this value should be a little familiar to you, because remember, that value is going to be our autoionization equilibrium constant value. And as we know, that value is 1 times 10 to the negative 14th at 25 degrees Celsius. And so this tells us something about the relationship between Ka and Kb. And it's that Ka times Kb equals Kw, which is 1 times 10 to the negative 14th. And this also tells us that pKa plus pKb is going to be 14.0. And of course, this is at 25 degrees Celsius. We can see this in a real example if we look at hydrofluoric acid. So hydrofluoric acid, the Ka value for that is 6.6 times 10 to the negative 4th. And then the Kb value is going to be 1.52 times 10 to the negative 11th. And if we add these together, you get the autoionization of water. And if you multiply the Ka and the Kb values together, you get that it's going to be 10 to the negative 14th, as we saw before. So the relationship, again, is that Ka times Kb is going to equal 1 times 10 to the negative 14th. And this little fact alone, this little relationship, helps us solve a lot of problems. So let's see what those problems look like. What is the pH of a 0.10 molar solution of NaCN? The Ka of HCN is 4.9 times 10 to the negative 10. So we're asked to find the pH of a 0.10 molar solution of NaCN. And this NaCN is going to dissociate into Na and cyanide ions. And so where is the pH going to come from? Well, the pH is going to come from this little equation here, where cyanide is going to react with water to produce HCN and OH minus ions. Now, we can write a Kb value for this, where Kb is the concentration of HCN times the concentration of OH minus all over the concentration of Cn minus. Remember, the water is not added because it's in liquid form. At this point, we can write out an ice chart. So we can say, we can write the ice chart of our reactants and our products. So cyanide and then HCN and OH minus. And so the initial is 0.1 molar, and the initial for these are going to be 0 and 0. The change is going to be minus X, and the change here is going to be plus X and plus X. So our equilibrium is 0.1 minus X. This can be plus X, and this can be plus X. So our Kb value really is going to be X times X all over 0.1 minus X. If we knew our Kb value, we could find out what the concentration of the OH minus was, and then using that we could find POH and then find pH. But the thing is, we don't know our Kb value. The only thing that we're given is our Ka value. So how can we turn that into our Kb value? Well, remember, Ka times Kb is going to equal 10 to the minus 14th. And so if we know our Ka is 4.9 times 10 to the minus 10th. So that times Kb is going to be 10 to the minus 14th. And we can solve for Kb, and Kb is going to be 2.04 times 10 to the minus 5th. And that's going to be our Kb value, which we can plug into our little form here. So 2.04 times 10 to the minus 5th is going to equal x squared over 0.1 minus x. The problem is that if we just left it like this, we would have to solve a quadratic, and quadratics are really annoying. So what we can do is we can turn our denominator into x squared over 0.1. And that's because x is going to be a really, really small number. And at the end of the day, it's not going to affect much of the value of our denominator. And you can do this according to something called the 5% rule, which I don't really want to go into, but essentially if your value here is less than 10 to the negative third, that's usually the threshold where you can just ignore that denominator value, or the x in the denominator value, and just solve that way. So if we were to solve this way, we would get that x is going to be 1.43 times 10 to the negative third. And remember, this is going to be our concentration of OH. So if we were to find POH, that's going to be the negative log of this number right here. That's going to be about 2.85. And using this, we can find our pH. So if we take pH and we add 2.85, that's going to be 14. And so pH is just going to be 14 minus that little value. So 14 minus 2.85 is going to be 11.15, which is answer choice D. And that is the right answer. So again, we start off with a 0.10 molar HCN solution. So that's going to turn into sodium and cyanide. And that's going to undergo a reaction here where it's going to produce some Kb value. And with an ice chart, we can find out the concentrations of the OH with respect to each other. And then if we were to find the value of Kb, which we found by just manipulating the Ka and the Kw values, we can find our Kb value and then use that to find the concentration of OH, relate that to POH, and then relate that to pH. And using that, we got the right answer, which is D. Let's do one more problem to end it off. A solution of ammonia, NH3, has pH of 11.5. What is the ammonia concentration? And we're given that the pKa of NH4 is 9.24. So we know that we have NH3. And NH3 is going to react with water to produce NH4 plus, and it's also going to produce OH minus ions. And using the information that we're given, we can determine a Kb value. So we know that this can be a Kb value since we're producing OH here. And so our Kb value is going to be the concentration of NH4 plus times the concentration of OH minus, and that's going to be over the concentration of NH3. And we can actually do a couple things here. First of all, we know that our pH is going to be 11.5. And so our POH is going to be 2.5. And using POH, we can reverse engineer the concentration of OH. So if you want to turn POH to the concentration of OH, you just take 10 to the negative POH. So 10 to the negative fifth. And that's going to be 2.5. That's going to be about 3.16 times 10 to the minus third. And this value right here is going to be our concentration of OH. And so our concentration of OH is going to be 10 to the negative third. And we can plug that into our Kb value here. One other thing that you can do is you can say that the concentration of OH is going to be the same as the concentration of NH4. And so what we have is that 3.16 times 10 to the minus third squared over NH3, the concentration of it, and that's going to equal Kb. And so since we're trying to find the ammonia concentration, we are going to need to figure out what Kb is. So again, pKa plus pKb is going to be 14. And since we're given pKa, we're told that it's 9.24. 9.24, that plus pKb is going to be 14. So if we solve for pKb, we're going to get that it's going to be 4.76. So pKb is 4.76. And if we want to turn this value into the actual pKb, well, pKb is just going to be 10 to the minus 4.76. And so our Kb value ends up being 1.74 times 10 to the minus fifth. And now we can solve for the concentration of NH3. So 1.74 times 10 to the minus fifth is equal to 3.16 times 10 to the minus third squared. Sorry, that should be a squared right here. All over the concentration of NH3. And all we have to do at this point is solve for the concentration of NH3. And the concentration comes out to about 0.58, which is answer choice D. And that is the right answer. Again, this relationship right here and the fact that Ka times Kb is going to equal 10 to the negative 14th is going to help us relate a bunch of Ka and Kb values and solve a bunch of other problems on the test. All right, that's all I have. I hope you learned something, and I hope you'll join me for part 4. Thank you for watching.